Hi, welcome to another algebra installment. Today we're doing Algebra 1, Section 4, Lesson 3, or Chapter 4, Lesson 3. So 4.3. And we are going to be talking about writing equations with parallel and perpendicular lines. Parallel and perpendicular lines. Parallel is noted by two parallel lines. Perpendicular is noted by a perpendicular line. So those are the symbols we'll use. So what are parallel lines? If you look right here, we have two parallel lines. This blue line and this red line. And what do we know about parallel lines? Well, we know that parallel lines never cross. These two lines will go on indefinitely, and they never cross. So, to define it, parallel lines never cross. Now let's look at the linear equation for parallel lines and see if there's anything we can find out there. This red line here is y equals 2/3 x minus 2. And this blue line here is y equals 2/3 x plus 1. What do you notice about the slope of both of those lines? The slope is the same. We have 2/3 and 2/3. So another thing with parallel lines is parallel lines have same slope. If lines are parallel, they will have the same slope every time. Parallel lines have same slope. Alright, now let's look at perpendicular lines. So let's take this one out and let's add a perpendicular line. If you see, this line crosses. It's perpendicular. And what perpendicular means is it crosses at a 90 degree. So these, the green and the red lines are at a 90 degree. They're exactly, essentially opposite. So those are perpendicular. So what do we know about perpendicular? Well, we know that they meet at a 90 degree. So perpendicular lines meet at 90 degrees. They meet at 90 degrees. And let's see if there's anything else we can tell about their slope from their equations. So here we have y equals 2/3 x plus 1. Y equals 2/3 x plus 1. And then y equals -3/2 x plus 2. 2/3 -3/2. 2/3 -3/2. So let's look at that. If we have a slope of 2/3, and that's perpendicular to a slope of -3/2, what do we notice? Oh, look. It's the reciprocal. Reciprocal, meaning it's flipped upside down. That's reciprocal. And also, this one's positive and this one's negative. So it's the negative reciprocal. So perpendicular lines have negative reciprocal slope. Perpendicular lines have negative reciprocal slope. So there's an example. 2/3 is perpendicular to -3/2. What about a slope of 1/3? Slope of 1/3. It would be perpendicular, if we flip this over, to -3/1, or -3. 1/3 is perpendicular to -3. A slope of 1/3 is perpendicular to -3. What if we have -5? Well, that would be perpendicular to 1/5. So see, this one's negative, so this one's positive, so it's the opposite. I'm sorry, we shouldn't say negative, we should say opposite reciprocal. Opposite reciprocal. So this one's negative, so this one's going to be positive. So we're going to say opposite. Opposite reciprocal. Negative 5 is parallel to positive 1/5. Cool? Okay, so there's a couple examples of reciprocal slopes. All right. If we look down here at the core concepts, two lines in the same plane that never intersect are parallel lines. Never cross, never intersect. Never cross or never intersect. So never intersect are parallel lines. Two distinct non-vertical lines are parallel if and only if they have the same slope. Same slope. All vertical lines are parallel, meaning that any line, right, if it's a vertical line and there's another vertical line, they are in fact parallel. All right, perpendicular, two lines on the same plane that intersect to form right angles. So right angles, that's 90 degrees, right? That's a right angle. Perpendicular lines meet at 90 degrees. Got it. Non-vertical lines are perpendicular if and only if their slopes are negative reciprocals or opposite reciprocals. I guess I could have left negative. Negative reciprocals or opposite reciprocals. Whichever one works better for you, opposite or negative, because this is in fact the negative of that one. Vertical lines are perpendicular to horizontal lines. You have a vertical line, then you have a horizontal line. Those in fact are perpendicular. Okay, so here we have a slope of -2, and that is perpendicular to a slope of 1/2. All right, that was page 103. Page 103. All right, moving on to page 104. So I will do the odds, and you can do the evens. So let's check this out. In exercise, determine which of the lines, if any, are parallel. So we're looking for parallel lines. So here is line A. So I'm going to do the slope for line A. So I'm going to make my triangle from a known point to a known point. So I go positive 1, 2, 3. So I have a rise of 3 and a run of 1. So there's my slope for A. Now I'm going to do my slope for B. Here's B. I have a rise of 1, 2, 3, 4, and a run of 1. So this is a slope of 4. So we know that A and B are not parallel. Let's check C. Here's my triangle. So I have a rise of 1, 2, 3, 4, and I have a run of 1. So look at that. B is parallel to C because, we need to explain, they have same slope. Because they have the same slope. So go ahead and find the slope for A, find the slope for B, find the slope for C, and see if any of them are parallel. Pause the video so you can get that done. All right, here we go. Number 3. Uh-oh, we don't have the slope on these. So it looks like we're going to have to find it. So let's find the slope for A. What I'm going to make is a table, X, Y table. So I have -4, -1, and 2, 2. So going from -1 to 2 is a +3. Going from -4 to +2 is a +6. So for A, my slope is 3/6, which is also 1/2. So 3 divided by 6 is 1/2. So A equals 1/2. Now let's go for B. Might have to use some other paper to get all of these, but let's check out B. So I have x, y. So x is -5, -3, and 5, 1. So -3 to 1, that would be 4. I add 4. -5 to 5 would be 10. So I have 4 tenths. If I divide both of these by 2, I have 2 fifths. So the slope for B equals 2 fifths. And now I'm going to run, it's getting kind of busy, but let's do C. C, I have x, y, -2, -3, and 2, -1. So from -3 to -1 is +2. -2 to 2 is +4. So I have 2/4, which is 1/2. So C equals 1/2. So if I look at these, A is parallel to C because slopes are equal. Alright, so basically what they've given us is two different ways to find out if we have parallel slopes. I had points, I had to find the slopes, and I had a graph, which I was able to count the slopes. Now we have a third way, which I'm going to do on a separate piece of paper. For number 5, we have line A, which is 4x equals -3y plus 9. We have B, I'm going to write these out, B, which is 8y equals -6x plus 16. We have C, which is 4y equals -3x plus 9. So, what I want to do is I want to find the slope of these to see if they're parallel. Now, none of them are written in slope-intercept form, so what I'm going to do is I'm actually going to move them to put them in slope-intercept form. So I'm going to add 3y, and to make it slope-intercept form, all I have to do is solve for y, right? 3y plus 4x equals 9 minus 4x minus 4x, and I get 3y equals -4x plus 9. Divide by 3. Y equals -4/3 x plus 3. So the slope for A is -4/3. Now I go to B. Let's solve for B. All I have to do for this one is divide by 8 all the way across. So then I get y equals -6/8x plus 2. -6/8, I can divide both of those by 2. So I get y equals -3/4 plus 2. So my slope for B is -3/4. So looking at these, it does not look like, oh, they were almost, they're reciprocals, but they're not opposite. They're both negative. So far nothing. Let's see what we get here. Divide by 4. Divide by 4. So we get y equals -3/4 x plus 9/4. So my slope equals -3/4. So if I look, I have a slope of -3/4, a slope of -3/4, and a slope of -4/3. So these are parallel. So B is parallel to C because slopes are equal. So I'm going to go ahead and put that in right here for number 5. B is parallel to C because slopes are equal. B equals negative 3/4 and C equals negative 3/4. Alright, if this isn't making sense, please call me or Zoom me and I'll explain this in further detail. I just turned each one of these into slope-intercept form. Slope-intercept form, which made it easy to find the slope. And once I found the slope, I compared the slopes. Alright, number 7. In exercise 7 and 8, write an equation of the line that passes through the given point and is parallel to the given line. Okay, parallel. So, the slope of my new line is going to be the same as the slope of this line. So I'm going to say my new line has a slope of 1/3 and it has a point of 3, -1. See, because it says it passes through this point and has the same slope. So I have these two. I have the slope and the point. You remember yesterday when you had the slope and a point, you were able to write it in point-slope form. So now we have a slope and a point, so we could write it, if you remember point-slope form, y minus y1 equals m times x minus x1. So y minus a -1 equals our slope times x minus 3. A negative and a negative equals a positive, so y plus 1 equals 1/3 x minus 3. There we go. You just wrote an equation in point-slope form. Write an equation. You can simplify it. You can finish this off. You can simplify it and write it in slope-intercept form, or you can just leave it like this. There it is. There's my equation. So try that with this one. Figure out what your slope is, and here's your point, and write an equation, a linear equation for that. All right, fun. Now we get to find out if any lines are parallel or perpendicular. Don't forget, parallel, same exact slope. Perpendicular is opposite reciprocal slopes. So let's look at these. Where's line A? There's line A right there. So we're going to say line A has a slope. Where's a known point? There's a known point right here. And here's a known point. So it goes up 1, 2, 3, 4. So it's a positive 4. And then it's a negative 2. 4 divided by -2 is -2. Alright, B. Here's line B. Here's our known point here and here. So we go 1, 2. So it goes up 2 and goes over 1, 2, over 2. So the slope for this one is 1. And then let's check C. Here's C. Here's our 2 points. So we go up 2 and then -1. So we get -2. So what do we know about these lines? Slope of -2, slope of 1, slope of -2. Looks like A and C are parallel. So A is parallel to C because slopes are equal. Alright, check these ones and see what you get. See if any of them are perpendicular or parallel. Alright, number 11. Here we've got one with several. I'm going to do this on a separate sheet of paper again. So number 11, I have a line that passes through -2, 4, 1, and 1. So I'm going to do line A, negative 2, 4, 1, 1. So this is negative 3. This is positive 3. So I have negative 3 over 3. So I have negative 1. So my slope for A equals negative 1. Maybe I'll set it over here. That's fine. B. So let's do our xy for B. So line B passes through 2, 1, and 4, 4. This is a positive 3. I add 3. And this is a positive 2. I add 2. So I get 3 over 2. So the slope for B is 3 halves. And then I go for C. So here we have C passes through 1, negative 2. Negative 2 to 4, that's a positive 6. 1 to negative 1, that's a negative 2. So I have 6 over negative 2. Divide both of those by 2, and I have 3 over 1. So the slope for C is 3 over 1. So what do I see here? Any parallel lines? Nope. How about perpendicular? I don't see any of those either. Plus 3, plus 0. Yeah. Unless I did my math wrong, I don't see any parallel or perpendicular lines. So you can even check me and see if it's correct. All right. So no parallel or perpendicular lines. All right. Number 13. So here we have three lines, and this one is already written in point slope form. So I know my slope. So line A has a slope of 3/4. I don't have to do anything to that to find its slope. Line B, negative 3y equals 4x minus 3. Well, this one is not written in point slope form yet. So y equals negative 4/3 x plus 1. So our slope for B is negative 4/3. And then line C is 4y equals negative 3x plus 9. So we divide by 4 across the board, and we get y equals negative 3/4 x plus 9/4. So for C, we have negative 3/4. Okay, so let's look at this. We've got a slope of 3/4. We have a slope of negative 4/3. Oh, look, reciprocal, opposite. Hey, A is perpendicular to B. And let's check negative 3/4. Oh, it's the reciprocal, but it's not the opposite. And here it's the same, so it's almost parallel, but they're opposite, so they're not parallel. So we have A is perpendicular to B. So for number 13, A is perpendicular to B because slopes are negative reciprocals. All right, number 15. Right. Actually, you know what? let's check, just to double check. No, we're fine. But you can always double check on Desmos. If you want to put in, you know what, let's do that. Let's double check number 13 on Desmos. So, for number 13, here we have y equals 3/4 x plus 1. That's line A from number 13. Then we have negative 3y equals 4x minus 3. That's line B. And then we have 4y equals negative 3x plus 9. That's line C. So there's our three lines. And if we look on here, this is line A, and this is line B, and look, those are perpendicular. Those are 90 degrees. And we can count the slope to double check, but those are 90 degrees. So sure enough, we said A and B are perpendicular, and C didn't relate to either of them, and that's what we got. So that was an easy way to check our answers. Don't be fooled into going straight to Desmos and doing your work, because then you're not going to be able to do these problems. Use Desmos as a tool to check. In fact, I might go back and check number 11 after this is done and see. Check that one. All right, number 15. Write an equation of the line that passes through the given point and is perpendicular to the given line. So, again, we're going to write in point-slope form. I'm sorry, we're going to write in point-slope form. Yep. So our point is negative 2, 2. And our slope is perpendicular. So if this slope is 2/3, that is perpendicular to what? Well, the opposite reciprocal, negative 3/2. Look at how easy that is. I got my slope at a point, and I just put it into point slope form, which I already have written here. Y minus y1 equals m times x minus x1. So y minus y1 equals m times x minus x1. So y minus 2 equals slope so x minus a negative 2. So that equals a plus. There it is. Go ahead and work on 16. Again, if you have any questions, let me know. Another good place, another great resource would be to go to Khan Academy. Khan Academy, and if you're in Khan Academy, all you have to do is search. You can search point slope form. You search point slope form, you're going to get these videos, intro to point slope form. If you search perpendicular lines, you'll get another search, perpendicular lines. So those are great resources. So give those a check. All right, thank you very much, and we'll see you in class.